120 volts. You must be familiar with doing these kind of very simple problems. Now, let's talk a bit about resistance. A conductor has a resistance. Now, resistance of a conductor depends on what kind of factors. Now, this is a conductor. Now, the resistance of this conductor depends on what kind of factors. Resistance depends on the length. Tell me, if the length of the conductor increases, will the resistance increase or decrease? Well, if the length increases, the charges have to go through a very long conductor, the resistance will increase. So, as the length of the conductor increases, the charges have to move through a longer distance, and therefore the resistance increases. As the length of the conductor increases, the resistance increases. That means we can say resistance is directly proportional to the length of the conductor. Resistance is directly proportional. As the length increases, the resistance also increases. How about the diameter? Tell me, if I make this thicker, if the diameter is greater, will the resistance increase or decrease? Alright? I thought I heard someone saying resistance increases. Did you say that? Well, tell me, if there is a narrow corridor and a lot of people want to go through that corridor, and on the right side we have a broad corridor, now where is the resistance of flow of people easy? As the corridor becomes wider, the resistance of flow becomes easier, becomes less. So, if a conductor becomes broader, if the diameter of the conductor is bigger, the conductor will be much broader then. It will be much easier for electric charges to flow through. So, as the conductor becomes more thicker, the resistance is going to decrease. A thicker conducting wire has a larger cross-sectional area, and this makes it easier for the charges to flow through the conductor. And so we say a thick conductor has a lower resistance, and a thin conductor has a larger resistance. So what kind of a relationship is there? This is an inverse proportion. Resistance is inversely proportional to the cross-sectional area. As the area increases, resistance decreases. As the area decreases, resistance increases. Alright, there is one more thing on which the resistance of a conductor depends on. Temperature. Alright, what do you think? If you increase the temperature, will the resistance increase or decrease? Now remember, you know that temperature, as you increase the temperature of a substance, its atoms and molecules will move faster. That means as the temperature increases, the atoms and molecules will be more agitated inside, and the electric charges will find it a lot more difficult to flow through. So as the temperature increases, resistance will also increase. As the temperature of a conductor increases, the atoms of the conductor will vibrate with larger amplitude, and this will make it difficult for the electric charges to drift through the conductor. Now, an increase in temperature therefore will cause an increase in resistance. Resistance of a conductor can be decreased by decreasing the temperature. In fact, if you decrease the temperature to a very low value, in fact, the resistance of the conductor will be made very, very, very low. Okay, let's now go on and talk about energy in an electrical circuit. Well, when electric charges move through electrical circuit, energy is spent. You see, you cannot move things from one place to another without spending energy. That means when an electric current flows through a conductor, energy is being spent? Well, a current in a circuit is caused by the motion of charges due to the force they experience in the electric field that exists inside the conductor. And therefore, work is done when electric charges move inside the conductor. Now, this work done appears in the form of energy in the electrical circuit. In order to drive electric charges, energy is spent, and that spent energy very often appears in the form of heat, light, and so on. Now, this energy might appear in the form of heat, light, motion, and other forms. We can actually use electricity to do all these things. Electricity can be used to produce motion. Electricity can be used to produce light. Electricity can be used to produce heat. All these are possible because electric charges moving from one place to another, energy is spent, and that spent energy appears in many forms. Alright? Now, tell me, what is the definition of potential difference between the ends of the conductor? How many of you remember? We gave a definition for potential difference between the ends of a conductor. Suppose I say the potential difference between the ends of this conductor is 1 volt. What does it mean? It means in order to drive a charge of 1 coulomb from one end to the other, we spent 1 joule of energy. 1 joule per coulomb is 1 volt. 2 joules per coulomb is 2 volt. 5 joules per coulomb is 5 volt. If I say the potential difference between the ends of the conductor is 5 volt, it means 5 joules of energy is spent to move 1 coulomb of charge from one end to the other. That is the meaning of potential difference. If the potential difference between the ends of a conductor is 1 volt, it means 1 joule of work is done for every coulomb of charge that flows from one end to the other. So then, if the potential difference is 1 volt, 1 joule of work is done for every coulomb of charge that moves from one end to the conductor. Now consider a conductor carrying a current I when the potential difference across its ends is V volt. Alright, try and answer this question. The current is I ampere. What does that mean? What is the meaning that current in the conductor is I ampere? Remember, an ampere is coulombs per second. So the current is I ampere means I coulombs of charge pass through this conductor in 1 second. Now, if the potential difference now is V, what does that mean? The potential difference is V. Potential difference is V means it V joules per coulomb. For each coulomb of charge that flows from one end to the other, the work done is V joules. But you know that there are I coulombs of charge in this conductor in 1 second. That means work done in 1 second will be, for each coulomb of charge, the work done is V joules. Therefore, for I coulomb of charge, the total work done will be I times V. So, what is the total work done in 1 second when I coulomb of charge cross the conductor? For each coulomb of charge that passed from one end to the other, work done is V joules. Now we have I coulomb of charge passing every second. So what is the total work done in 1 second? The total work done in 1 second is I times V joules. Now, this work done in 1 second is a measure of the energy converted from electrical to other form in 1 second. And this is called the power of the electrical circuit. Alright, I want you to learn that. The power of an electrical circuit is P equal to I times V. Power equal to I times V. The unit of power is called the watt. A joule per second. Unit of power is the watt. And 1 watt is 1 joule per second. Electrical power is measured in watt. Don't you go and buy a 60-watt bulb? A 60-watt bulb uses 60 joules of energy in 1 second. That is a 60-watt bulb. Alright, what did we say a 60-watt bulb is? Do you remember? What is a 60-watt bulb? Well, when a 60-watt bulb is turned on, it will use electrical energy at the rate of 60 joules per second. That is the meaning of a 60-watt bulb. Now, if it is turned on for 1 hour, how many joules of energy will it use? A 60-watt bulb, when it is turned on for, well, it uses 60 joules of energy in 1 second. So how many joules of energy will it use when you turn it on for 1 hour? Can you do that on your own? Well, you should be able to do that. The amount of energy used in 1 hour will be 60 joules per second multiplied by the number of seconds in 1 hour is 60 times 60. And that will be 21,000, is that right? 216,000 joules is the amount of energy that a light bulb, a 60-watt bulb, uses in 1 hour. That's a lot of energy. Let's do a problem. What is the current in the filament of a 60-watt bulb when connected to a 110-volt supply? Well, we need to find the current in the filament of a bulb when you connect the bulb to a 110-volt supply. Now, what are the given things that we have? We know that the power is 60 watt. We know that the voltage is 110 volts. Now, can you recall the equation for power we just obtained a few minutes ago? Power in an electrical circuit is voltage multiplied by current. Well, we know the power, we know the voltage, we want to find the current. Can you solve this equation for current? Is P equal to V times I? What will be I equal to? Alright, to get I, we divide both sides by V. We get I equal to P over V. So we got P equal to 60 watt and V equal to 110 volts. Therefore, the current in the filament of that bulb will be 0.55 ampere. Now, I want you to take a few minutes and do the following. Alright? Now, this is what I would like you to do. The purpose of every electrical circuit is to supply the energy to operate various electrical devices. Is that right? Now, these are devices. Now, these devices are constructed to convert the energy of flowing charge into other forms of energy. For example, the energy of flowing electric charges can be converted to light, thermal energy, that is heat, sound, mechanical energy, that is rotation, and so on. Now, use complete sentences to describe the energy conversions which occurs in the following devices. What is the energy conversion that takes place in the case of a windshield wiper on your car? Electrical energy is used to do something there. What kind of energy conversion? Electrical energy is converted to what kind of energy there? I want you to write a full sentence about it. Defrosting circuit on a car. Now, what kind of energy conversion is taking place there? The hair dryer. Now, complete this and email it to me. Write at least one sentence each. You can write 2 or 3 sentences to explain yourself. Is that right? To explain to me what kind of energy change, electrical energy is changed to what forms of energy in each of these. Alright, let's now talk about what is called a unit of electricity. Now, how many of you know that you pay for electricity? Well, I'm sure all of you know, because you pay for electricity. Now, how do you pay for electricity? What is the criteria for paying for electricity? We pay for electricity for each unit of electricity you consume. Now, how much is a unit of electricity? What is a unit of electricity? Alright, I'm going to explain a unit of electricity. Listen carefully. If a 1000 watt bulb, tell me, what is a 1000 watt bulb? Well, you know, if a 60 watt bulb is something that uses 60 joules of energy in 1 second, what is a 1000 watt bulb? A 1000 watt bulb uses 1000 joules of energy in 1 second. Alright, if a bulb like this, a 1000 watt bulb, is turned on for 1 hour, how many joules of electricity are consumed? This bulb uses 1000 joules every second. So, how many joules of energy are consumed in 1 hour? Can you do that? A 1000 watt bulb consumes 1000 joules of electricity in 1 second. And 1 hour contains 3600 seconds. Therefore, the amount of energy consumed by the bulb in 1 hour is 1000 joules multiplied by 3600, and that is, look at that, that's 3.6 million joules. Is that right? 1, 2, 3, 4, 5, 6. Yes, it is 3.6 million joules of energy are consumed by this bulb in 1 hour. And this much energy is what we call 1 unit of electricity. That means when you plug in a 1000 watt bulb and leave it on for 1 hour, that bulb will use 1 unit of electricity. Now tell me, how many of you know how much do you pay for a unit of electricity? Do you look at your electricity bill? It tells you how much they charge you. Well, next time you get the bill, look at it and learn about how much do they charge and how do they charge. It's all in the bill actually. Well, in Florida you pay approximately 10 cents a unit. That means for all this energy, 3.6 million joules of energy spent in 1 hour, you pay about 10 cents. Okay, so a 1000 watt, now 1000 watt is a kilowatt, is that right? 1000 is a kilo. So a kilowatt bulb used for 1 hour consumes 1 unit of electricity. And so, can I call 1 unit of electricity as a kilowatt used for 1 hour. A kilowatt hour, in fact, a unit of electricity is called a kilowatt hour. 1 kilowatt used for 1 hour is 1 unit. 1 unit of electricity is a kilowatt hour. So, this much electrical energy is 1 unit of electricity. Well, 1 unit is called, look at the name of that unit. It's called a kilowatt hour. Why is it called a kilowatt hour? Because it is the amount of energy used at the rate of 1 kilowatt for 1 hour. And that is a kilowatt hour. And look at the abbreviation we use. Small k, big W, H. This is kilowatt hour. Small k, big W, small h. Kilowatt hour. So 1 unit of electricity is 1 kilowatt hour. 1 kilowatt hour is the amount of energy consumed at the rate of 1 kilowatt for 1 hour. That means if you turn on this bulb for 10 hours, how many units of electricity will be consumed? It will be 10 kilowatt hour. If you turn on that bulb for 50 hours, it will consume 50 kilowatt hour of energy, or 50 units. Okay, in that case, tell me this. If I have a 2 kilowatt electric heater, a 2 kilowatt, you know what it is? 2000 watt. A 2 kilowatt electric heater, I turn it on for 2 hours. How many units of electricity are consumed? Well, if 1 kilowatt is turned on for 2 hours, it will consume 2 units of electricity. 2 kilowatt turned on for 2 hours will consume 4 units of electricity. Right? That's simple. So, kilowatt hour, which is a number of units, can be calculated by multiplying the power in kilowatt by the time in hour. That's all you need to do to calculate the number of units of electricity you use. The number of units of electricity you use can be calculated as the power in kilowatt multiplied by the time in hour. That will give you the number of kilowatt hour you used. Alright, let's do an example. What is the cost of operating a 500 watt electric heater for 20 hours if electricity cost 8 cents a unit? Now the first thing to do is to write the power in kilowatt, because we are looking for kilowatt multiplied by hour. Kilowatt hour. A unit of electricity is a kilowatt hour. Tell me, 500 watt is how many kilowatt? Well, the power is 500 watt, means 0.5 kilowatt. 1000 watt is a kilowatt. 500 watt is 0.5 kilowatt. And the time it is used is 20 hours. So, in order to find the number of units, you multiply the power in kilowatt by the time in hours. So the cost, and the cost per unit is given to be 8 cents, $0.08. The number of units is power used in kilowatt multiplied by the time in hours. And that is, the power in kilowatt is 0.5 kilowatt and the time in hour is 20 hours. And that gives you 10 kilowatt hour is the amount of the number of units you consume. And each unit costs $0.08. Therefore, the cost is 10 multiplied by 0.08, That is $0.8 or 80 cents is the cost of using that heater for 20 hours.